Hello everyone, my name is Alessandra Cervone and I'm presenting the paper Is this dialogue coherent? Learning from dialogue acts and entities. This is work done during my PhD at University of Trento together with Giuseppe Riccardi. The main research question that we ask ourselves in this work is what makes a response coherent in dialogue? Let's start with an example. We have a dialogue context where speaker A says, "Do you have a PC?" and speaker B, "Yes, I have a Mac." Then we can consider different candidates to be the next turn in the dialogue. For example, "Do you like dogs?" Or, "Yeah, a lot of friends are into Mac, I have a PC myself." Or, "I don't know." Instinctively, as humans, we would say that some of these examples are more coherent with the context than other ones. The task we address in this work is exactly this one, evaluating the coherence of next turn in open domain dialogue given a dialogue context. So why is this work relevant? First of all, dialogue evaluation is still an unsolved challenge, especially in the case of open domain dialogue. On the other hand, coherence is a fundamental property of human communication and can be described as what makes a text rather than a random group of sentences. However, most recent research in open domain dialogue relies on surface text, without digging deep into which conversational attributes make a response coherent. In this work, we argued that there's still much to understand regarding substructures that affect human perception of turn coherence in dialogue. We see the applications of our work not only in open domain dialogue evaluation, but also in open domain dialogue modeling. Questions relevant for this work are what makes the turn of a dialogue coherent, but also is there an underlying discourse structure and what factors contribute to it? The NLP community has attempted to answer some of these questions by focusing on the role of entities with entity-based coherence models. Entity-based models capture recurrent patterns of distribution of entities in a coherent text, as we can see from the connections between the center candidate and the context. However, research on entity-based coherence is mainly focused on text, such as the news. And unfortunately, to the best of our knowledge, there is currently a lack of publicly available dialogue resources annotated with coherence. On the other hand, the dialogue but also linguistics research communities have widely studied dialogue acts in connection to dialogue coherence. Dialogue acts can be regarded as generalized version of intents. Also in this case, this literature posits that a coherent dialogue, such as the one in the center, is characterized by particular patterns of distribution of dialogue acts, which establish links among subsequent turns. So for the original question, what makes a response coherent in dialogue? In this work, we specifically decided to investigate potential substructures made by entities and dialogue act patterns of distribution as a signal of turn coherence in dialogue. More specifically, we investigate two research hypotheses. The first one is, do DAs and entities affect the perception of turn coherence in dialogue? In order to investigate H1, we annotated a switchboard coherence corpus, a new resource of spoken dialogues annotated with turn coherence ratings, which is available at the link below. Then, to validate H1, we perform a statistical analysis of turn coherence rating in the switchboard coherence corpus in connection to dialogue acts and entities and their combination. Our second research hypothesis is, can we model dialogue act and entities to predict turn coherence in dialogue? In order to validate H2, we investigate different coherence models, and we also propose novel neural models based on entities and dialogue act information. Then, in order to test the H2, we perform a series of experiments. In particular, we propose to use response selection as a weekly supervised training task and then test our models on the turn coherence rating task on the switchboard coherence corpus. Let's get into more details. The source data of all of our experiments is the switchboard dialogue act corpus. For our response selection experiments used as a training task, the data is automatically generated. The task here is to rank the next turn candidates given a context. Examples are automatically generated by randomly picking a point K in a dialogue and using the dialogue history up to K as the context and considering the original next turn, K+1, as the positive sample. Then we could consider as negative samples random turns either from the same dialogue, a technique which we call internal swap, or from other dialogues, a technique which we call external swap. In this way, we produce our dataset by randomly picking 10 insertion points per dialogue, and then for each one having a pool of 10 next-door candidates for both ES and IS. Then for our main task, turn coherence rating, we create the switchboard coherence corpus. In this case, the task was to rate next-door candidates' coherence given a context. The initial data was generated by selecting 1K context, each one paired with a pool of 7 candidates. Each turn was annotated by 5 workers using Amazon Mechanical Turk, with a rating scale between 1 not coherent and 3 coherent. We obtained an inter-entity agreement of 0.66 and an averagely one-out correlation of 0.78. Then, in order to validate H1, we perform a statistical analysis of the switchboard coherence corpus. In particular, we used multiple regression analysis to verify the correlation between entities and dialogue acts patterns of distribution and human coherence ratings. We created features based on entities, such as the number of new entities or the number of overlapping entities in a candidate, and also features based on dialogue acts. Our results, according to multiple correlation coefficient R² and adjusted R², indicate that both entity and dialogue act information significantly correlate with human perception of turn coherence, especially if combined. Motivated by these findings, we then proceed with our experiments for verifying our second research hypothesis. For these experiments, we used several baselines, such as the entity grid, which we call SVM and row, that is an SVM model based on a grid representation of patterns of transitions between grammatical roles of entities in the dialogue. In this case, S is the subject, O object, and X is just the presence of an entity. A second baseline is SVM-DA, taken from Cervone et al., also based on a grid representation, but of the information. Our third baseline is also an SVM from Cervone et al., combining the previous two. We then proposed a series of neural models based on a novel linearized representation of the structure of the dialogue in terms of entities and dialogue acts using IOB tags. In particular, we investigate models relying on entities information, where on top of grammatical roles, we also propose lexical-based and turn features. We also investigate models relying only on dialogue act information. And finally, models which combine both entity and dialogue act information. All our neural models rely on a simple architecture based on bidirectional gated recurrent units and an average pooling layer. As evaluation metrics, we use pairwise accuracy and ranking metrics, in particular mean reciprocal rank and recall at K, for both response selection and turn coherence rating. Additionally, for turn coherence rating, we use normalized discounted cumulative rank, which also takes the rating into account. For all our metrics, we choose a conservative evaluation where if 2 candidates are given the same rank by the model, we assume the model always made a mistake. Here are our results on response selection. As mentioned before, besides a random baseline, we have different baselines based on entities and dialogue acts. Then we have our proposed neural models based on entity information, on dialogue act information, and on their combination. For neural models, we report the average of 5 runs using different seeds. Looking at the results, we notice how our proposed models in general perform better than our baselines based on the same features. Additionally, for both data generation techniques, the best performing models are the ones combining entities and dialogue acts patterns of distribution. Finally, here are the results of our main task of turn coherence rating on the switchboard coherence corpus. First, we observe how also here the best performing models across both condition ES and IS are the ones combining both dialogue acts and entities. Additionally, we notice how for response selection, ES seem to perform better as a training methodology in general, especially when entity information is used. So finally, for our conclusions and future work, In regards to H1, our statistical analysis results show both entities and dialogue act patterns of distribution correlate with human perception of coherence in dialogue, especially when these two types of information are combined. And in regards to H2, again, the best performing models on term coherence rating are the ones combining dialogue acts and entities information. Another main contribution is that we share the switchboard coherence corpus, which is a novel resource for term coherence rating in open domain spoken dialogue. Finally, in regards to our next steps, we would like to experiment with large pre-trained models on the tasks such as BERT or Roberta, although these models typically rely on surface text, while in our framework, we rely only on entities and dialogue acts information. Therefore, it wouldn't be a straightforward task adapting these models to our framework. Anyway, thank you for your attention.